So, today for your 2.3, you should know what a system of linear equations is. That is just two or more linear equations. Okay, so a system could consist of a set of two, it could consist of 3, 4, 5, however many equations. When it's more than one, it's considered a system. A consistent system is a system that has at least one solution. Okay, now an independent system is a system that has exactly one solution. Okay, and then a dependent system is a system that has infinitely many solutions. And then an inconsistent system is a system that has no solution. So we're going to be classifying, once we graph the two equations, we're going to have to look at where they intersect. We're going to look at what situation we have on our graph, and we're going to classify. So you're going to have three options. You're going to have consistent and independent, or you're going to have consistent and dependent, or you have inconsistent. Okay, so what you've been doing when you've been solving it algebraically, you've been getting an ordered pair, or last class when you had a system of three, you had an ordered triple. Okay, and that represented the solution that meant that it was true for all the equations in the system, and that's the only ordered pair or ordered triple that was true for everything. Okay, so graphically, that ordered pair represents the point of intersection if you were to graph those lines. Okay, so what we've done algebraically, we get our ordered pair answer. That's what we're going to look at graphically and see where they intersect. That point of intersection will be the ordered pair that you write. So your ordered pairs are still going to be your answers. Okay, that's going to be part one. Part two is going to be your classification of what we just did. So this part is the new part that we didn't do in Algebra 1, but with a little bit of memorization, you will be good. Okay, so when you're graphing, your first thing to do is make sure it's in y equals mx plus b. Remember that slope-intercept form. Okay? When you get it in y equals mx plus b, remember that the number in front of your x, that m, is your slope. And slope is rise over run. Remember, you use your slope to make the points on your graph for your line. And if it's positive, you're going to go up and to the right. If it's negative, you're going to go down and to the right. Okay? And then the b in slope-intercept form is your y-intercept. That's what we plot first. We plot that point on the y-axis and use our slope to create the line. Okay? Once you graph your lines, you're going to see where they meet. Wherever they meet, that's your ordered pair. That's your answer. Okay? If they do not cross, you have no solution. So what type of lines are not going to cross? Parallel. So if I have parallel lines, it's going to be no solution. If they end up being the same exact line, that's when you have your infinitely many solutions. Okay, now linear equations, we're using the slope-intercept form that we solved for, but if we have absolute value equations, we're going to have to do t-charts like we did last chapter when we did absolute value equations, okay? You're going to have a few problems like that, and we're going to revisit vertex form for absolute values and how to identify and build that table, okay? So the first example, I've got x equals 2 and y equals x minus 4. I already have that in the form I need, okay? If I look at x equals 2, that's a special case line. I've got y equals a number, and I have x equals a number. Those are my two special cases, if you remember that. If it's y equals a number, it's a horizontal line. If it's x equals a number, that's a vertical line. Okay, so x equals 2 is a vertical line going through 2 on the x-axis. Thank you. I put the rulers up here by the notes. I don't know if y'all saw that or not, but if you feel like you need a ruler, y'all can go ahead and get one now. Sorry, I should have told y'all that before I started. I just started. So then on the next equation, I've got y equals x minus 4. What would my slope be for this equation? I don't have a number, so it's understood to be 1. And then my y-intercept would be negative 4. So I'm going to plot negative 4 on the y-axis. And my slope, I'm going to go up 1 to the right 1. Now, when you draw your graphs, it takes 2 or 3 points to make your line. If you want to make sure you're accurate so you get a good solid point of intersection, I would do as many points until you can see them intersect, just to make sure you're not crisscrossing them at an odd spot, okay? Also make sure that your lines go all the way across the graph and you have your arrows. Since it is a continuous function, I will take off if you don't have arrows. Okay, if you don't have your arrows, it changes it from a line to a line segment. So I've graphed my two lines and I look at where they meet. So right here is my point of intersection, and that is at 2, -2. So that would be my first part of my answer. And then I have to classify it. Okay, so if I classify it, I've got exactly one solution. So that's going to be consistent and independent. Y'all good with that? Okay. When I look at the next example, I've got 3/2 x plus y is equal to -2 and -2x plus y equals 5. I'm going to have to solve for y equals mx plus b for both of those. So I'm going to go ahead and copy it down. If I'm solving for my y, I need to get rid of my x, and I need my x to get on the opposite side. Okay, even though that's a fraction, that's still part of my x term, so I got to move that entire term over. How am I going to do that? I'm going to subtract it. This is positive, so I'm going to subtract 3/2 x. So I drop my y, and that's equal to, remember you're doing mx plus b, so I bring my -3/2 x down, and then I copy down the -2. Okay, so I've got that equation solved. What's my slope? -3/2, and my y-intercept would be -2. Okay, so I'm going to plot -2 on the y-axis, Now it's a negative 3 halves, so when it's a fraction, the numerator is your rise, the denominator is your run. So if it's a negative 3, I'm going to go down 3 and to the right 2. So from this point, I'm going to go down 1, 2, 3 to the right 2. Down 1, 2, 3 to the right 2. Now, if I didn't have space, if I had a very low y-intercept and I didn't have space to go down and to the right, you can always backtrack it and go up and to the left. Just make sure you're falling from left to right if you have a negative slope. So that's a way to kind of check yourself and make sure your graph looks right. Okay, so then I'm going to look at negative 2x plus y is equal to 5. I need to solve for y. So I'm getting my negative 2x to the other side by adding 2x. And y will equal 2x plus 5. What's going to be my slope? What's my y-intercept? So I'm going to plot 5. And I'm going to go up 2 to the right 1. If it's a whole number, you only go over 1. Now I can see if I keep going upward, I'm not going to crisscross it there, but if you want to backtrack it and go down 2 to the left and down 2 to the left to just make sure you're crossing at a good point, you can do that. You don't have to, but I like to do that to make sure I'm accurate with my lines. And then I can see my solution to the system would be what? Negative 2, 1. And it's got exactly one solution, so my classification would be consistent and independent. So I say the difference between consistent and independent versus consistent and dependent. Think about if you want to be independent, you want to be by yourself kind of. So that one solution is by itself. If you want to be dependent, you're going to depend on something else. You're going to need something else, and that's where your IMS comes from. Okay? If you need help keeping those separate, sometimes that might help you. Now, when I look at example 3, I need to solve those for y also. So if I'm solving for y, I need to get rid of my 2x. So I'm going to subtract my 2x. So I have a negative 3y is equal to a negative 2x plus 3. And then what do I need to do? I divide every term by negative 3. So y is equal to, I have a negative divided by negative, so that's going to turn into a positive. 2 divided by 3 is going to leave me with 2/3 x. Now before I put this plus, I need to look, when I divide by negative, I got to make sure my signs are right. Okay, so I'm dividing a positive divided by a negative, so that's going to be a negative 1. Do not make the mistake of putting a plus negative. Okay, I will count off for that. You either have a positive or you have a negative. There's no in between. Okay. So here my slope is going to be 2/3 and my y-intercept is going to be negative 1. So I plot negative 1 on the y-axis. It's a positive, so I'm going to go up 2 to the right 3.
Teachers and students, excuse this interruption. Today we have a shelter-in-place planned. Shelter-in-place will be called upon if there's some type of chemical.
So now we can draw the line and then solve for the second equation. Alright, so to solve for the second equation, If I'm solving for my y, I'm going to do what with my x? I'm going to add 4x. 6y is equal to 4x minus 6. And then divide each term by 6. So y will equal 4 divided by 6 simplifies to 2/3 x. Negative 6 divided by 6 gives me a negative 1 again. So this is the exact same line. When that happens, I'm not going to require you to plot the points again. Just put 2 more arrows on that line, and that's going to show that you got 2 lines. They're just the exact same line. So then my solution is going to be IMS. Because if the point of intersection is my solution, and it's the exact same line, technically they are intersecting at every possible imaginable point. Okay? So then, since it's IMS, it's going to be consistent and dependent. Okay, so then if I look at 2y equals x plus 8, I would take each term and divide it by 2. And y will equal 1/2 x plus 4. So then my slope is a 1/2. My y-intercept is 4. Plot your 4. And I'm going to go up 1 to the right 2. Then my second equation is already in y equals mx plus b form. So my slope is 1/2 again, and my y-intercept is -2. So when I plot my -2, I'm going to go up 1 and to the right 2 for this line also. And that's going to form what type of lines? Parallel. So when you recognize they're the same slope, that's what's causing it to be parallel. So then my answer would be what? No solution. And inconsistent. Okay, so what we're going to do is we're going to look at this next one. I've got absolute value for that next equation, for my first equation of the next example. So remember that your absolute value vertex form is y equals a times the absolute value of x minus h, and then you tack on that plus k at the end. And my vertex was always hk. So that means whatever is inside those absolute value bars with your x, remember that that's the opposite sign. So you're going to need to identify your vertex first, and that's going to help you build your table. Okay? So if I've got my table, and I'm looking at the absolute value of x minus 2 minus 1, my vertex is going to be the opposite of -2, so it's going to be a +2 and then -1. And that goes in the center of your table, and you'll do 2 points above and 2 points below. So to get those 2 points above, remember you're just subtracting 1 each time. So I'm going to have a 1 and a 0, and then I'm going to add 1, 3, and 4. Okay, now to get those y values, you can take those x values and store them. So 0, store for x, and just type in the absolute value of x minus 2 and then the minus 1 at the end. That gives me a positive 1. Then I'm going to do the same thing for 1, store that for x, and then I'm going to go up and grab what I already have typed so I don't have to type it again, and that's going to give me a 0. Y'all remember doing this? Okay. 3, store for x, go back, that's going to give me a 0. If it did not give me a 0, that means my vertex is wrong, or I typed it in wrong. Okay? So remember that it's a symmetric graph, so that your y values should be mirroring each other around that vertex. Okay? So I'll plot those points and draw. Remember, it makes the shape of a V. And once I do that, I need to solve my second equation for y. So I'm going to add 4x. 3y will equal 4x plus 3. Divide everything by 3. And y will equal 4/3 x plus 1. So my slope will be 4/3. My y-intercept would be 1. So I'm going to go up 4 to the right 3. And I can see that they're going to intersect at what point? Right here, which would be 0, 1. Okay, and then my classification, since it's exactly 1 point, would be consistent and independent. Now, if I have an absolute value equation and my second equation is a horizontal line, it would cross it at 2 points. So if my equation was just y equals 1, it would cross it at 2 points, and my answer for the classification would just be consistent. You wouldn't have to put the independent part because you technically have 2 points as your solution instead of just 1. Bless you. Okay, so example 6 we're still going to do because I want to point out what happens when we have this fraction for our table. When we build the absolute value table, the center should be my vertex. What's my vertex for this example? It's the opposite, -1, 0. So if I were to just do 2 above and 2 below, okay, if I were to do -2 and -3 and 0 and 1, when I plug those in, I'm going to get fractions in my calculator. So if I were to take -3 store for x and type in my 1/3 times the absolute value of x plus 1, it gives me 2/3. Okay? If I were to do -2 store for x, it gives me 1/3. And then I know, since I've done it, it's going to mirror around that vertex. Well, I'm not going to graph a 0.3 and a 0.6 and that be my graph. So if you have a fraction here, just go until you get your next whole numbers. Here, it's going to be at -4 and 2. Okay, remember that I said you could skip in terms of the denominator. But be careful when you do that because you have something now inside those absolute value bars. So just be careful if you want to start skipping. On the answer key, it's skipped. So this would be -1, -4, and then -7. And it would be 2, and then another 3 would give you 5. So on the answer key for your worksheet, it might be skipped to only whole numbers. If you're doing it like this, that's okay. Okay, because I'm teaching you that way. If you want to do it until you get a whole number here, since I know what they are, you go until you get 2, 1, and -4, 1. So if you want to just use your vertex in these 2 points, you can do that because it's still going to be symmetric. It's still going to give you the absolute value graph. Okay? If you wanted to plot your 1/3 and 2/3, you should still be able to split those into 3 sections and still be able to plot those points. I'm not requiring you to do that. I'm just going to look at your whole number ones for your table. Okay? So then my second equation is x minus 3, so my slope is 1 and my y-intercept is -3. So when I plot those two, they intersect at 5, 2. And that's going to be what type of system? If I have exactly one solution, it's going to be consistent and independent. Now good with that? Okay, so those are your 2.3 notes. And then we're going to do the 2.4 notes.